Hello everyone, it's Benny, and in this video we're talking about parallax displacement mapping, a technique that lets you take a polygon and make it look like it has a lot more geometry than, well, it actually does. For example, all these planes are just two triangles, but it looks like there's actually some 3D geometry behind them. And that's what we're talking about today. Now, I've already made a video on how this technique works, so if you're wondering about that, you should go look in that video. But if you want to know how this technique can be implemented in a practical application, that's what this video is going to be about. We're going to be taking a 3D game engine that doesn't have any parallax mapping, and I'm going to be showing you how to add in parallax displacement mapping. And yeah, so let's go ahead and let's get started. So, here we are inside the example 3D game engine. Now, if you don't have a 3D game engine to follow along with, I'll provide a link to the 3D game engine I'm using in the description, and you can download and build it based on that. And if you have trouble setting it up, I'll also leave a link to a video which shows you how you can set it up. And there. Now, one very important thing to note before we even do anything. In this video, I'm going to be presenting parallax mapping as sort of an extension to normal mapping. Now, parallax mapping and normal mapping are two separate techniques. They don't depend on each other, they can work independently. But it really works best when it is used with normal mapping. So that's why I'm presenting it as sort of an extension to that. As a result, you will need to have followed along with the normal mapping set, or tutorial, the normal mapping tutorial, before you can follow along with this. That's sort of a prerequisite, if you will. So if you don't already have normal mapping, you'll probably want to go ahead and get that set up before you do any of the parallax mapping stuff. And yeah, so with that, that's really all I have to say. And yeah, let's go ahead, let's dive in, and let's set up the example scene. So if you followed along with the normal mapping tutorial, your example scene might look something like this, with the normal mapped monkey head and this normal mapped plane. And it looks alright. But let's switch it around a bit. Let's switch it to the scene that I'm using for, that I'm using for the parallax mapping. Now in this, I'm switching the plane to use the basic bricks, and the monkey's things to using bricks 2. So, I'm just going to change that. However, I am also changing the monkeys to be planes, so I'm going to change that to plane 3. Other than that, that should be everything. So if I build and run, there you go. These are the two planes and the bricks that I used in the example scene. And those are some really shiny bricks. So let's tune that down a bit. Let's make this something like, I don't know, specular in factor of 4, so it's not so focused, and 0.5f for the intensity, just so you know, it's not as intense. There you go. That's a lot better. Not perfect, but a lot better. So there, this is our example scene. This is what it looks like with just textures and normal mapping. And in this video, we're going to extend this to have parallax mapping. So, first thing I'm going to do is I'm going to modify my shaders so that they have parallax mapping. So, in case you forgot where the shaders are, from the project folder, which looks something like this, you go to 3D Engine CPP, to Res, to Shaders. Now, the big thing I need to change here is the lighting things. So I'm just going to open up all the lighting shaders, and we'll see what we need to do and what we don't. First thing is the vertex shader. The really big thing here is you're going to need the TBN matrix, like I explained when I was explaining the technique. So yeah, we're going to need this to rotate the eye direction and such. So yeah, make sure you have that. If you have that though, like we do in this, you're good. And you should have that if you did normal mapping. So we actually don't need to do anything in the vertex shader. Now, in lighting, we don't really need to do that much either. This is just doing the lighting calculations and such, so we don't really need to change this. I am going to leave this open though for a moment, but we don't need to change it. So the big things we need to change is our sort of header file for the lighting shader, and the actual main function of the lighting shader. So, how do we change the main function? What do we need to do? Well, remember, parallax mapping is just a texture coordinate thing. You're just changing the texture coordinate so that it looks like there's some perspective and displacement all over the place and such. Yeah. So, what I'm going to do is I'm going to create a new variable, vec2, called textchords. And for now, I'm going to set that equal to textchord 0. And basically, I'm going to be using this in place of everywhere that I had textchord 0 before. So, this is going to be textchords rather than textchord 0.xy. And this is also going to be textchords rather than textchord 0.xy. So there. Now we've changed it to a variable. All we have to do now is apply the parallax mapping to the textchords variable, and that's it. Then parallax mapping will be applied to the normal map and to the actual diffuse map, and everything will be good in the world. So how do we do it? Well, remember, the whole parallax mapping calculation centers around the direction to I. How do you get that? Well, that's why I have the lighting shader open, because we already did this calculation somewhere. It's this right here. So I'm going to copy this variable, put it, say, right here, and there. So now we have the direction to I being calculated with the I position and the world position, and we do have, we want to change this to world pos 0 because, well, that's what it's called in lighting.fsh, but other than that, yeah, we should be okay with this. So we have the I direction. Now what? Well, first off, this is an offset, so we're going to need to add something to it. What we need to add is direction to I. But, remember, direction to I. Right now, this isn't relative to the plane. So we need to multiply this by the TBN matrix, the one that will rotate it into the same orientation as the plane, in tangent space, whatnot. You know, it'll just be in the same orientation as the plane and such, and there. So our direction to I is appropriate now. It's in the right space. Yeah. It's basically for the same reason normal mapping, just needs to be rotated to the same place as the plane. But yeah. So now we've got that. It's rotated in place. Now what? Well, there's a few different ways you can actually use this value. I'm going to go with one way you can use it, and that's just to take .xy. That'll give you the sort of 2D part of it, the xy, the part that's, well, you know, the 2D part. Well, yeah, it's taking the 2D part relative to the texture. So this is sort of, if you can think of it like this is how far the direction is in 2D space relative to, well, the texture itself. Because that's accurate. So, there. We now have our direction to I relative to the texture, the 2D part of the direction to I relative to the texture. So what? Well, now that we have the actual direction, the direction we need to offset in, if you will, what we can do now, just add the displacement value. Now we get the displacement value, if you remember, by reading from texture 2D, texture 2D, there we go. And what we want to read from is the displacement map. We don't have that declared yet, but it'll be there. And we want to read that at whatever our textchord 0.xy is. So, you know, that value. Whatever our normal textchord's at. And again, this is an approximation. This won't be accurate if, well, I don't know, textchord 0 happens to be at a spike, and the point we're actually trying to get is a perfectly flat place, so, but for the most part, this is a good enough approximation. And there. So, now this does return a vector 4, remember, RGB and alpha. But the displacement map should be a grayscale image, so you can just sample any component you want. I'm going to go with the red component, but yeah, it really doesn't matter. You can just read any component, and it should be the same, because, again, grayscale. And that's it, really. You have the offset, which is based on the I vector, and you're scaling it by the amount of displacement that should be happening at that point. And that calculates the offset. You're adding that to what the texture coordinate was before, and boom! You've got displacement mapping, or you've got parallax displacement mapping working just fine right here. There are a few things you might want to do, though. The big one being, this, as it is probably going to give you way more parallax displacement mapping than you want. So you're probably going to want to scale this by some value. So I'm going to multiply this by displacement map scale, which is going to be some uniform. And I'm also going to add some displacement map offset. Or actually I'll call it displacement map bias. This is just some default amount of displacement so that, you know, we can always have... well, because remember, this value starts off... when you read from a texture, it gives you a value between 0 and 1. By that measure, we're not really going to have any values that are below the plane. We can't make a crevice in displacement mapping. So we're probably going to want to add some value that takes it down a bit. So, yeah, just to take the displacement map down a little bit so, you know, we can have those crevices and valleys and whatnot in there. And that's what the bias is for, just decreasing it a bit. And that's it, really. All we have to do now is declare our displacement map uniforms, and we should be good. So, in our lighting header, I'm going to define uniform sampler 2D displacement map. That's, guess what, the displacement map. And of course, I'm going to have my uniform float displacement map scale and uniform float displacement map bias. And cool. We have taken in all the uniforms. We have the calculation in place, and it's being used. And that's honestly almost all there is to displacement, or parallax displacement mapping. All we have to do now is just feed in the values, and we're done. So, since we have new uniforms in our shader, we're going to need to change our material a bit. So, I'm going to add a comma here, and let's add in some new parameters. I'm going to have a texture pointer for the displacement map, and it's going to be going to be a new texture. It's just going to have default disp.jpg. And if you look under res/textures, there is a default displacement.png. Excuse me, wrong file format. So So there, default displacement.png. Make sure you're using the right file format here. And the reason we can use new here and still have the memory be cleaned up properly is for the same reason we could do it with the normal map. Because at the end, when the material's being deleted, it's going through all the textures, and if the texture hasn't been deleted somewhere else, it's deleting it. So these will get cleaned up. That's, yeah, just want to clarify, that's why that's okay. If you're doing something like this, it's not in most cases it's not recommended, but in this one case it does happen to work out. So yeah. And gonna add a texture for the displacement map. It's gonna of course be whatever's passed in as a displacement map. And there. So we've got the displacement map in. What do we need now? Well, the next two values we need are the displacement map scale and displacement map bias. However, those values I've found are actually a little bit hard to actually set, well, the amount you want in. So I'm going to change these. We're still going to have displacement map scale, but we're going to have the second value is displacement map offset. And here's how we're going to sort of get the bias and scale from that. Of course, we do have just proper displacement map scale being taken in, so we can pass that in as displacement map scale. The tricky one is the bias. So for displacement map bias, if I spell it right, and did I spell it right in the shader? It's kind of important. Yes, I did. Okay, just being paranoid. Now the way I'm going to get that is I'm going to have some float I'm going to call sort of base bias. And that's just going to be the displacement map scale divided by 2, or 2.0f. And the default bias is just going to be the negative base bias. And the reason I'm doing it like this is because let's say I have displacement map scale of 2 for something. I don't know, just for instance. So it's going up 2. It's taking the values, it's mapped, so the texture values are now between 0 and 2. Cool. That doesn't have any room for ravines. It's just going up to 2 place points away from the plane. And that's nice, but you know, chances are you're going to have something that goes into the plane at least a little. By that definition, nothing ever even intersects the plane. So what this is doing is it's setting the bias to the scale over 2. So if it's 2, that's 2 over 2, which is 1. And negative. So we're just subtracting 1 from the value. So in that case, if, again, the displacement map scale is 2, this will be between -1 and 1, because we're subtracting that half the scale from it, which was 1. So we're subtracting 1, blah. We're getting -1 to 1. So see, that's the way this is sort of working. No matter what the scale is, it's sort of mapping it to a range. It's always being sort of centered at 0. So if scale was 4, the scale would start off as 4, so it would be mapping between 0 and 4. This would be 4 over 2, so that would be 2. And we're subtracting 2 from 4, so it would be from -2 to 2. So see how that's working? It's just sort of being... the scale is sort of scaling away from 0. And yeah, that's the way that's working. Hope that makes a little bit of sense. If not, you can play around with these values and you should be able to figure out what I mean. But how do we incorporate the offset? Well, what I want to do is pretty simple. I'm going to start with the base bias, but I'm going to add base bias multiplied times displacement map offset. And, well, that's it really. We're adding. So this way we can just add in extra bias. Again, all relative to the scale, but you know, just to offset it a bit. And there. So if this is 0, then we're good. And there. So yeah, that should give you just an idea of how this should work. I'm going to set the default scale to 0.04 because I find that's generally the ballpark range of what you want the values to be without them looking really weird. And I'm going to start the displacement map offset off at 0. And there. That should give us a proper looking material. Finally, all we should have to do is go in the rendering engine. Well, almost all we have to do. Again, you'll see. Add in the sampler location for a displacement map. I'm going to set it to location 2 because that's one we haven't used yet. And there, we should be almost but not quite good. You'll see. So by default, this shouldn't do anything. Our displacement map should be new. Actually, you know what? Even better yet. One moment. Okay. That's okay. But better yet, I'm going to say the default scale is just nothing, because that way, with the default displacement map, we're not getting any displacement at all. So there. If we just build and run. Yeah. No displacement. It's working just like before. So good, at least the defaults aren't screwing anything up. But how about we add some displacement mapping to something? So right here, let's add in a new texture here, called bricks displacement.jpg. And let's set the displacement map scale to, oh, I don't know, 0.03f, sure. That should be something. We should be getting some displacement mapping, right? Sort of? Not really? What's going on here? Where's displacement mapping? And well, things haven't quite worked out yet. Just yet. So let's take a step back and let's realize what we've done wrong. Where we screwed something up. Why is it that even though we've added the parallax displacement mapping code, this isn't showing up? You know, maybe it's that texture. Oh, I know why. Actually, there's an issue I didn't notice, and that's that bricks displacement here, that's actually a .png file. Yeah, so if I try again, yeah, now we get some sort of displacement mapping, or parallax displacement mapping, but it doesn't look quite right. You know, it's sort of swimming a bit. What's going on here? Why are we getting that? And well, there's a reason for this, believe it or not. The reason is, we haven't changed the ambient shader. You see, the ambient shader, that's being run before everything else, and it's also putting the default color in. But as you see here, the default color is just the diffuse at the normal texture coordinates, no parallax displacement mapping involved. So that's getting us this sort of odd effect where you can still see just a little bit of that default in there. In fact, if I disable the directional light, like, I don't know, if I just don't add the directional light at all, this should make this problem a lot more pronounced. Like, see here? Yeah. If you look here, it just looks flat and normal, but then you have this where it looks like there's displacement mapping, and it looks really weird because the textures aren't matching up anymore. They're not generating the same texture output in both passes. And yeah, it looks a bit off. So, the way we solve that is simple. We're going to need to add parallax displacement mapping in the ambient shader too. And sort of a convenient thing about this is this actually means that our forward ambient.vs looks exactly the same as our lighting.vs. So, well, yeah, so I can just include lighting.vsh here as our forward ambient header. The fragment shader is going to be a little trickier because we're going to need to have the actual parallax displacement calculation, and it's going to be weird and blah. So what I'm going to do is I'm going to create a header. I'm going to call it sampling.glh. Sampling.glh. And this is going to include a function for just calculating the texture coordinate offsets. So it's going to be vec2. I'm going to call it text coord displacement. I'll call it text coord offset. How about that? And this is pretty much just going to be an extraction of these lines of code right here. So it's going to take in some sampler 2D, sampler 2D, there we go, called displacement map, to read in, because that's, again, what this is using. Let's see, we need matrix 3, TBN matrix, to rotate the direction vector. Speaking of, we also need a vec3 direction to I. What else? And we also need vec2 text coord. And I think that's everything. I could be wrong about that, but I think that's everything. So, I'm just going to copy that calculation and say, really, just return this. Now, I won't need this thing right here because I'm just calculating the off. Well, yeah. Okay, how about this? Calculate text coords from displacement map. There. Okay, how about this? Calc parallax text coords. How about that? There. Concise, gets the point across. So cool. Text coord is again, you're going to need to replace with text coord, so that's the variable here. Direction to I is good. Ah! And I'm also going to need some float scale and float bias, which of course is going to be replaced with replace those. Much better. So now we have a function in a header file that calculates parallax displacement. So I should be able to change our lighting main here to include the sampling.glh and use that function. So text coords, rather than being this, they're going to be calc parallax text coords from the displacement map and the TBN in matrix. Basically, almost all the parameters are named the same, so I'm going to just copy and paste and be lazy like that. So yeah, direction to I, text coord 0 as the text coords, be careful about that. Scale and bias are going to be, well, displacement map scale, and whoops, and displacement map bias. So cool, we got text coords calculated from the parallax mapping thing. Actually, I'm going to undo this briefly just to test this out, just to make sure I haven't screwed something up here. Should be good. Should be able to run. And cool, we still have some parallax displacement on the bricks. Great, things are working. So now the ambient shader. Now that we have that in sort of a function library, I can redo that, including lighting.vsh. And now here I need pretty much to do the same thing I've done in lighting main. I need to calculate texture coordinates just like that. And I'm going to need to actually use those in place of text coord 0. And that'll output the proper diffuse texture, and that'll help the swimming problem a bit. So, how do we do this? Well, of course we need the displacement map now, so we need that uniform sampler 2D displacement map. I'm no longer getting C_I position just from the lighting, so I'm going to need that. Uniform vec3 C_I pos. World pos 0. Need varying vec3 of world pos 0 and also going to need the varying mat3 of TBN matrix. Both of those are passed in by the vertex shader. So that covers that. Direction to I is being calculated. Good. Text coord 0. Oh yeah, it's being taken in. That just leaves scale and bias, so just need to take in uniform float displacement map scale. And finally, one more thing for displacement map bias. So we're taking in all the parameters needed, and it should be calculating, well, ambient pass with... Oh, well, clearly I've screwed something up here. But yeah, I think the general idea is here. I've just made a typo somewhere or something, so yeah. One moment, I'm going to find where I've screwed things up. And it was very simple. I just forgot to include sampling.glh. Once I do that and run, hey, look at that. We got our parallax mapping. Texture isn't swimming as much. It looks nice. Now, there's still some texture swimming, like right here. Yeah, that's a particularly bad culprit right there. And this is sort of the artifact I was talking about when you have sort of extreme changes in your height map. In this case, the crevices are a bit of extreme change. You're going from mostly up to almost completely down, and that's what creates texture swimming like this. And there's not much you can do about this without actually changing the displacement map, but there's a little bit you can do to help. For example, look at the brick. See the brick right in front of me right now? Pay attention to that as it gets to the edge of the screen. Alright, see how sort of as you get towards the edge, sort of like black parts start showing up from the crevice texture? Yeah, that is one effect you can help a bit. And the way you can do that is just with the offset bias. So, wait, what? Wait, what? Okay, I don't know exactly how that happened, but you don't want it... Oh dear. Yeah, you don't want it to do that. But yeah. One thing that can help that is a displacement map offset variable. You might want to offset it down by, say, I don't know, 1.0f. And, yeah, that can actually prevent the texture from going up the edge. So you see, okay, yeah, it's not going up the edge as much. You don't really see it going up the edge anymore. It has made the crevice a little bit look like it's on a pendulum or something, so, yeah, maybe 1.0 is a little bit extreme. Let's try something like negative 0.5f. And, okay, it's not quite as much of the pendulum effect, and as it gets as texture getting towards the edge, we're not having the sort of black part swim up the edge. So, again, you can play with this a bit and see what works well. I think this is okay for the purpose of demonstration, so I'm going to leave it like that. But yeah, you can play with that all you want, get some nice looking parallax effects. So just in conclusion, let's go ahead and add the parallax mapping to the bricks 2. You know, just have something there. So, you can add new texture here. It's going to be bricks 2 underscore displacement.jpg. And yeah. And for scale, I'll say that it's 0.04. Sure. Let's see what happens. Let's build. Let's run. And, look at that! Parallax mapping. And, ooh, see, you're getting sort of some of the texture build up on the edge. Yeah, looks nice. Let's add a bit of an offset. Let's try negative 1.0. Okay, there's before. Here's after. Alright, look at that. Alright, so you see, there's no longer building up on the edge, so actually for this particular displacement map, 1.0 seems to be just a perfectly fine offset. So yeah. And this also gives you a nice sort of before and after. Before, just with normal mapping, and after with normal and parallax mapping. So yeah.
And that's all there is to implementing parallax mapping. Of course, you can implement parallax mapping on other texture if you want. But yeah, that's all there is to it. So you can play around with this, do whatever you want. And yeah, enjoy parallax mapping. Thank you. Hope you enjoyed. Hope you learned. And see you next time.